Welcome back, everybody. This is part 2 of chapter 10, where we're talking about actual linear regression. And so let's jump into it. Given a collection of paired sample data, the regression line is a straight line of best fit of the scatter plot of the data. The regression is, so this is the actual equation. Now, X and Y are unknown. A and B are going to be specific values, and I'm not even going to show you the formula on how to find those because our calculator will do that for us. However, the X is called the predictor variable, also known as the independent variable. Y is known as the response variable, and making this the dependent variable. Now, you can think back to your algebra class. You remember y equals mx plus b. I know this might be bringing back some bad memories for some of you, but can you see in this case, it's exactly this, except m is b in this case, and b is a in this case. So a is the y-intercept. B is the slope, sometimes referred to as the direction. And here's the whole thing. We can get a linear regression line from any pairing of data. There's going to be two ways to predict things. One of them is we use the linear regression line. That's this one here. Or we use the mean. Now, if there's a linear correlation, we're going to use the linear correlation regression line. If there's not a linear correlation, then we're going to use the mean, y bar, meaning. So let's start a little slow here. Suppose IQ scores are obtained from randomly selected couples. For 20 such pairs of people, the linear correlation coefficient is 0.916. And the equation of the regression line is y equals 0.3 plus 1x, where x represents the IQ score of the shorter partner and y represents the IQ score of the taller partner. Also, the 20 x values have a mean score of 101.21, and the 20 y values have a mean score of 101.6. What is the best predicted IQ of the taller partner, given that the shorter partner has an IQ of 102? We're going to use 0.05 as a significance level. So first off, let's start here. Rho equals 0. There's no linear correlation, or rho does not equal 0, and there is a linear correlation. And let's see if there's a linear correlation or not. And we have n equals 20 in this case, and we have 0.05 for our significance. So to find the critical value, I'm going to go to my Pearson correlation coefficient table, and we are down here at 20, and 0.05 is here. So it looks like 0.444. All right, let's mark that up. So this is our no-go zone here. So if we're in here, there is no correlation. However, if we are out here, then there is a correlation. So they have already given us what R is, so we didn't have to figure that out. R is way out here. So this is 0.916. So there is a linear correlation. So the best predictor is y hat equals, what is it, 0.3 plus 1x. Not y bar in this case, which was 101.6. So let's use our predictor. They want to know when x is 102. So this is our best predictor. So in this case, using the mean was not necessary. Now, if there was no linear correlation, then we would have used that value. Let's do another one. An sample of 100 women is obtained, and their heights in inches and pulse rates, beats per minute, are measured. The linear correlation coefficient is 0.207. And the equation of the regression line is y hat equals 17.9 plus 0.920x, where x represents the height and y is the pulse rate. The mean of the 100 heights is 63.6 inches, and the mean of the 100 pulse rates is 72.4 beats per minute. Find the best predicted pulse rate of a woman who is 70 inches tall. Use 0.01 significance level. All right, first off, let's see if there's a linear correlation or not. And they tell us that n is 100 and we're using 0.01. Here, way down here. So 0.01 is this column. So we're here, this is 0.256. So we have a very small here. And we already know that 0.207 is R, and that is right there. So we're in the non-correlation zone. So no correlation, no linear correlation. So use the mean, which is 72.4 beats per minute. So we are not using our linear regression line in this case because there is no linear correlation. So our best predictor is going to be the mean, 72.4 beats per minute. All right, let's move on. To our next problem here. Okay. Here we have data on the chest size and weight of bears, 6 bears in this case. So n is 6. And we are going to go all the way through with this one. So first we're going to find the regression equation by letting x be the chest size and y be the weight. Now, my stuff is in, this is L1, I've already put it in, and L2. And so we're going to find the linear regression equation. Now, if you remember, it looks like this. And we need A and B. So I'm going to go ahead and run the linear regression test, t-test, with list 1. Once again, just to remind you how to change that. It's above the 1, second L1, and then L2. Calculate, and here's the great thing. They give us A and B. So they actually calculate that out for us. So let's mark that down. Part A, y hat is A plus bx. A in this case is -307.98 plus 12.47x. There it is. Right. A and then B. B. Find the mean of both x and y. Well, if you remember, the way you do that is we go to stat and calculate, and we do one var stats. Now I'm going to do L1 first. That's going to be x bar. There's x bar, 46. So x bar 46. Now I'm going to run the same thing, but on list 2 for the y values. That's these. All right, so stat, calculate, one of our stats, and that's going to be L2 now. All right, so 265.67. 265.67. And this is, of course, in inches, and this is in pounds, LPMs. All right, so if there is no linear correlation, then this is going to be my best predictor. If there is a linear correlation, then part A is going to be my best predictor. Let's go on to part C. Find the best predicted weight of a bear with a chest size of 41 inches. And we're going to use alpha of 0.05. So let's see what we got here. N is 6 in this case, right? 6 bears. 0. And N is 6. We have 0.05. Let's go to our table here. N is 6, 0.05. That's 0.811. So in between, again, is our no linear correlation. And if we're between the -1 and or 1, then we do have a correlation. So let's run and see what our linear correlation coefficient is. Oops, let's go up. There we go. List 1, list 2, good to go. What is our 0.979? R is about 0.9, which is about right there. So there is a linear correlation. So y hat equals -307.98 plus 12.47x is the best predictor. And they say on part D, I'm sorry, 41 inches. So y hat is going to be -307.98 plus 12.47 times 41. Let's see what we get. So -307.98 plus 12.47 times 41. So this is about 203.29 pounds is our predicted value. All right, that's all part C. Part D. So once again, I used the linear correlation line that I had here because there is a linear correlation. And I just replaced the X with the 41 they give us there to get 203.29 pounds. All right. Is the result close to the actual weight of 273 pounds? I have to say sadly no. 203.29 is not close. to 273. Now, things like this can happen, obviously. All that means is we didn't get the right 6 pairs. we need a much larger sample size there. Because maybe there really isn't a linear correlation. But based on our data, it is. All right. Below is a list of actors and actresses' ages at the time of winning their awards. Let X be the age of the actress and Y be the age of the actor. Find the linear regression line. I put this into my calculator already. This is my list 3 and my list 4. You may pause the video but we're going to go ahead and so I'm going to run stat test linear regression t-test, and this is now list 3 and list 4. All right, so I'm getting y hat is 52.5, we'll say, minus 0.198 x. B, find the predicted age of the actor, given that the actress that year was 28. So let's see if there's a linear correlation. Now there are, did they give us a count how many? No. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's 12. Now they don't give us an alpha, so we'll use 0.05. 12.05, 0.576. So 0.576, negative 0.576. All right. And let's see what R is. R is about negative 0.36, which is here, which tells us there is no linear correlation. So no linear correlation. So our best guess is going to be Y bar. That means I'm going to do 1 var stats on L4. So second 4. So our best predictor is 44.8 years old. Uh, 44.83 years old is the best predictor. So because there was no correlation, it didn't matter how old the actress was. Is the predicted age close to the actual age of the actor, who was 39 years old? Not really. So let's see. Not really. So you can see when there's not a correlation, then our guess isn't all that great. Just finding the mean is the way to go for it. That is chapter 10.